So what we're going to talk about is the physics behind the CDs. I know this topic might feel kind of old. That's how people listened to their music before Spotify came out. And the CDs had such a big impact when they were invented in 1982. Since they basically changed the music industry because they were pretty easy to record, it allowed the music artists to customize it and express themselves. They were pretty easy, they were pretty portable. Lastly, the radio stations were able to switch music faster. But it didn't only change the music industry. They were also a way to store data, and they were the basis of the development of the DVD. So how does the physics from class relate to this? Well, so to understand this, we have to see first like how it works. Well, the CD is plastic that has an injection of polycarbonate, and this has little bumps that are arranged in the form of a spiral. And after this, it's sprayed with aluminum and it's printed under acrylic. But how can the information be read? Well, it works by focusing a 780 nanometer laser that hits the bottom of the CD with a certain angle while the disc is rotating, and then this laser bounces off at a certain angle, generating refraction, what we saw in class, and then the sensor reads the information and sends a burst of electric current to an electronic circuit, which is later converted into sound.
Okay. So one of the ideas that we didn't focus on as much in class is diffraction. So diffraction is when a light beam is spread out instead of concentrated in. In a CD player, the laser is passed through a diffraction grating that makes 3 central beams. And a diffraction grating is just an element that helps to focus the spread out light beams based on their wavelength, as you can see in the picture. These central beams pass through a polarizing beam filter, which horizontally polarizes it. This polarized light is then focused through an objective lens onto the disc. Polarization is a way to filter light, which allows only some beams to pass through. In this case, all light except for horizontally polarized light is blocked from passing through the lens. This helps to focus the laser beam, making it easier to read changes in reflectivity level. So polarization is a property that transverse waves have, and it just shows which way it will oscillate or like move through the air. Some of the math included in CDs includes the motor, which spins it at about 1.2 to 1.4 meters per second. And we can see the relationship between speed and angular velocity. And angular velocity is used instead of linear velocity because it is a circular object, and so it uses the radians instead. The fraction, the formula for that uses the distance between the bumps in the CD, the diffraction angle, the order number for the maximum, and the wavelength of the laser. And then another thing that also fits into the math is the binary code used for the CDs. So when the sensor is tracking the levels of reflection that are bouncing off the CD, the change in that level will be recorded as a 1, and as it stays constant, it is recorded as a 0. This is recorded in the form of an 8-bit byte, which is then transferred into a 14-bit value through the process of 8 to 14 modulation. And this binary code can then be transferred into sound, which is played.
Well, thank you so much for listening to the video. This is everything from us, and I hope you understand a little bit more about how the CDs work, and these are like all the sources that we use.